All right, so I'm going to continue with number 11. And number 11, it talks about a straight trail with a uniform inclination 13 degrees. And so if you could just basically imagine a trail, it obviously has an inclination of 13 degrees, so we're here. There's 90% or 90-degree angle. It says the total here is 8,900 feet, but we're looking at it to about here, which takes away 900 feet. So 900 feet is the change, and we're left with 8,000 feet here. And then they want to know how long is this trail. So in this case, the solution is very simple, where we are going to I'm gonna put this, we're gonna take the 8,000 and we're gonna divide it by my calculator, sine 13. So 8,000 divided by sine 13 degrees. Let's see. Make sure you're in degree mode. And you should get, so in degree mode, notice that I always ask you to pay attention to the mode that you're in. You do notice they're asking for a side, but they are giving you an angle in degrees. So 35,653 is the estimated length of the trail. This is number 11. Your number 12 is actually very simple as well. You have to go back to the concept of the 30, 60, 90 triangle. So let's just look at that quickly. That doesn't matter where you put the 30 degrees, 60 degrees, as long as they're opposite each other. So remember, this 60 degrees, square root of opposite of that is always square root of 3. Opposite of the 30 degrees is always 1. And I told you to forget about proper English, so you can remember that that's the hypotenuse. All right. So if I'm looking at cosine of 60 degrees, and I'm multiplying that times sine of 30 degrees, and then I'm adding this sine 60 degrees times cosine 30 degrees. All right, let's go back to our triangle. So cosine 60, cosine of this is 1/2. Sine of 30 is 1/2. And we're multiplying these. So if 1/2 times 1/2 is 1/4, this comes to 0.25. 0.25. Enough. If I do sine 60, so would be square root of 3 over 2. And if I multiply that times cosine, I would also get square root of 3 over 2. So this is times. All right. And if we multiply this out, you notice that you end up with 3 over 4. So this will be 0.75. Added together, your final answer is 1. What I do want to just remind you of, and this is something you'll see on the SAT possibly, when you multiply two radicals, you're simply canceling the radical itself. So in this case, that becomes 3. And 2 times 2 gives you 4, hence 0.75. Okay. Now, we have talked about cofunctions. And when talking about cofunctions, one of the things that I've mentioned to you is that they're equal to each other. So for example, if I do 10 theta, that is equivalent to cotan of pi over 2 minus theta. So if this is by chance, in the way they're explaining it, this is equal to 2, well, doesn't that mean that cotan pi minus theta is equal to 2? And it's as simple as that. So that just goes back to show you that you have all the answers in your mind. On number 14, do you notice that you have 1 plus sine squared 85 plus sine squared 5, which gives you sine squared 90? Technically isn't sine of 90 in the quadrantals. If you remember when we talked about the quadrantal angles, that this is 0 degrees, this is your 90 degrees. And we know that this coordinate point here is 0, 1. And sine is all about the 1, all about the y. So in this case, 1 plus 1 is 2, and that's your answer. That simple. All right. Let's look at question 15. And in question 15, or actually 16, I'm looking at negative 1/2. I'm looking at 1/3 as a coordinate point that they're giving us. And they want us to find cosine, my apologies. They want us to find the cosine of theta given that information. So I want you to look at your denominators. And the way I approached this question was I said to myself, okay, I think I'm looking at the wrong question. I said 15 and I'm doing another question. So my apologies. We're looking at 15. They're giving you the coordinates negative 1/5 and positive 1/2. And they want us to find the cosine of theta. So quite simply stated, if you look at the values, I'm looking at this as 2 over square root 29. And the reason why I say square root 29, remember you have negative 5 squared plus 2 squared. Well, that's 29. And I have to take the square root of it to get the R, the R value. And so once I do that, all I need to do at the end is rationalize by multiplying by square root 29 and square root 29. Remember, the radicals cancel. You're left with a final answer, 2 square root 29 over 29. I believe, again, that is number 16, number 15, my apologies. On our review, I'm looking at the review, so there should be 15 for our review. And that answer should be 2 square root 29 over 29. Okay, another question here, number 16 on the actual review. You have cosine theta is equal to 2 over 5. You do remember that this is x over r. And this is, I believe, chapter 5.4, we started talking about this. So this means the x value is 2, our r value is 5. So if I'm drawing some random triangle, this is 5. Let's say this is theta, this would have to be 2. The question is, what goes here? So you have a hypotenuse and a side. So that tells me that you're going to have to square the denominator to get 5 squared minus square the numerator, which is 2 squared, which gives you 25 minus 4, which leaves you square root 21. So the value of sine, if this is square root 29, square root 21, the sine of this would be opposite over hypotenuse. So square root 21 over the hypotenuse of 5. So this would also have to be, if I'm thinking of it as sign, in this case, they're saying where tan is negative. Tan is negative in the second quadrant, which means this has to be negative. That means our x value is negative. Okay. In this case, remember the acronym that we shared in class, and we talked about A, smart, trig, class. So tan is positive in both of these quadrants. In these two quadrants, tan is negative. And so that means that our diagram is on this side. If tan is negative, tan is negative. Actually, I argue with myself now. I'm thinking it's either this side or that side. Regardless of the fact, your answer should be a negative. That is given. Okay. I argue it's the fourth quadrant one. That's why it would be. So we're looking at bow ties all around, right? Remember, formal wear only. So I'm thinking bow ties all around. So if this is going this way, this is going this way. So according to this, our hypotenuse, which is square root of 21, our y value is 5, and our x value is 2. So we're looking at that quadrant. All right. Number 17. Take a quick gander at 17. 1, 2, 4. Yeah, 17, 18. Okay, so I'm going to get a new one here. I'm getting to the end. All right. We have been given a reference angle of 5.2. You can do this one of two ways. It's up to you. If we simply take away pi, so let's go one route. Let me see if in radian. I have to be careful with my mode. Okay, so if I take away 3.14 twice, I end up with negative 1.08. I want you to consider the reference angle and consider it in terms of degrees. So if I go with 5.2 times 57.3, think about it as degrees so you can see the big picture. So if I do this, I get an angle of 297.96. This may not give you the insight that this will give you here, which is why I'm showing you the two ways. At this point, for the reference angle, I want you to think of 360 minus, I'm sorry about this pen, my technology sucks this year. So let's go with 360 minus the 297.96. Which gives me 62.04. And this is in degrees, by the way. Okay, so we're going old school, as I call it. If I divide this value by 57.3, which is 1 radian. Okay, so divided by 57.3, I get approximately 1.08. It's also a positive number. And it makes a difference in your answer, so be careful. how you approach the question. Remember, reference angles basically tell me where we end up and how far I am from the x-axis. So am I here? Am I here? Am I here? What's the distance between the terminal side of that angle and the 180 axis? Okay. So that one should have been answer choice C. Let's check the answer down here. And it looks like we're good. That's number 17, I said, right? Yeah, I said that was 17 and I said C. So C should be our answer for that one. All right, very good. The next one should be known to you because technically this is an SAT concept. It has to do with the Pythagorean triples. So if you just off the top of your head, think about the fact that this is -10, 24. You don't have to use Pythagorean theorem to find it because you already know that. This is a 5, 12, 13 Pythagorean triple. So in other words, what's missing is a hypotenuse. We know this is -10. We know this is 24. And we know that when we do the math, this is 26. Again, half, half, half will give you the Pythagorean triples. All right, so they want sine theta. So if theta is sitting here and I want sine theta, I'm looking at opposite over adjacent. Okay, remember this is the x, remember this is the y, and this is the r. So that's why we know this should be answer choice A for number 18. Again, let's check the math. A it is. All right. Let's take a look at 19 and 20. Those will be the last two on the second video, I'm sorry. So at number 19, see where we are. Okay, so for this one, I have the cotan of theta. And they're telling me this is equal to -3/2. They want me to find cosecant. So we know that, okay, so go back to some basics. We know that tan as a ratio is y/x. And therefore cotan as a ratio should be x/y. Cosecant is matching up with sine. I know that sine is as a ratio y/r, and cosine as a ratio is x/r. So if that is the case, then I need to find r. So imagine some triangle, random triangle, I don't care. I just know for a fact that in this case, the x value is -3. So this is -3, y is 2. I need to find r. So 2 squared plus -3 squared is equal to 4 plus 9, which is 13. And they're asking me to find cosecant, which, as I said, is the inverse of y/r. So this is r/y. So this is equal to, it looks like, that's my question. This should be square root of 13 over 2. Remember that this is r squared initially. So r is equal to the square root of 13. So if this is 13, and I happen to be looking at the sine, this would be, so initially this would be so let's say this angle is here, opposite over hypotenuse. This is hypotenuse over opposite. That's what cosecant is. So you need to remember these ratios. Answer choice A is your answer for this one. And for number 20, they're telling you that the sine theta is equal to -4/9. Once again, they are pointing out to the fact that we have tan theta is greater than 0, so it's positive. So all, or a smart trig class, where in this case, we know that where tan is positive. So it's either going to be the first quadrant or the third quadrant, right? And they're giving me a -4 and a 9. So I'm thinking -4, 9. And if I do the math here, let's see here. It looks like this is 81 minus 16. Let's see, this is number 20. Oh, they want the secant. So secant reverts back to cosine inverse. So 1 cosine would give us cosecant. So, okay. Let's go back to the basics. (81 minus 16). Well, that's going to give us 65. Keep that in mind. So 65 is part of your answer. Because remember, this is this is y over r. And so our r is 81. So we're looking at a triangle where this is 81. According to this, our 4. So the 81 is here. X over r. I drew it wrong. My apologies. All right. So in this case, this will be, I need another page. So let me go to another page. Okay, so one more time. Here's your quadrants. Let's draw our quadrants. Again, 10 is positive. Because they're telling us that tan theta is greater than 0, so it's positive. It's either positive here or here. It's going to be negative here and here, so I'm not going to bother with those two quadrants. They did tell us that our point is -4 and 9. So remember that sine -4 and 9, this means that this is y over r, if you could. So y over r, we're looking at our numbers sitting here as such. So if this is -4 and this is 9, which is really 81. So let's draw a triangle and let's do the math. So this is going to be r squared, x squared plus y squared. So x squared plus y squared equals r squared. Okay. So that means that we don't have x, so x squared plus -4 squared is equal to 9 squared. So x squared is equal to 16. Plus 16 is equal to 81. Subtract 16 on both sides. So x squared is equal to 65. And so x is square root of 65. Okay, so what you need to remember is, again, they're asking you for secant. If they're asking me for secant, secant's the opposite of cosine. Cosine, so just to remind you, cosine is x over r. This is r over x. So the r value that we have is 9. And this is over x, which we have square root 65. but we rationalize the denominator. So if I multiply by square root 65 over square root over 9 as well, I get 9 square root 65 over 65. And because we're in the third quadrant, cosecant, cosine is negative, so therefore secant is negative. And so therefore answer choice, I want to go with B. Answer choice B is going to be for 20. Let's see. Yeah, so 20 is B. All right. I'm going to pause the video here because I'm sure you're tired of hearing me yammer on. I'll start the next set in a minute.